Hello everybody. So this is my response to homework number 10. I'm sorry that it took quite some time. I kind of thought that I've done that already and then I realized that I didn't. Sorry about that again. So so for today you were supposed to play a bit with the Pokemon data file. I think most things worked out for you one way or the other. Again, I mean, as we can see, I will show today several different approaches, and it's really up to everyone's liking what kind of approach they use, and depending on the situation and one might be better than the other, or one person is used to this and one person is to use something else, and both usually have some merits and some demerits as well. Also, I think exercise number 5 made trouble to many people, so we're gonna talk about that as well. So first is exercise number 1 was basically practicing the iLog and log function. So generally speaking, I mean, when you use the log function, you have to give the label either of the column or of the row so you can access the data. The ilog function is like an integer log function, so you give it an integer, so the things work pretty much the same like in NumPy arrays, or when we are used to use just simple indexing from simple arrays. So here, for example, I mean, when we are using, of course, when we are using column, the easiest is if we know the name of the column or the label of the column. That's the easiest way how to access it in Pandas. But you can also use the ilog or log, and that depends, of course, if you want the whole column or just some part of it. As you can see here, if I'm trying to look at the row, I mean, here using ilog and log is exactly the same, or it looks like it's exactly the same, but here it is 4 in ilog, that's an integer 4. Here, this is the label 4. So because we don't have any labels for the rows, automatically the data frame has label 4, and so you can use this, but basically I think this translates the 4 into the number 4, the integer 4, into the string 4, or into the character 4. All right. And so, of course, if we want to access a specific row, and we know, for example, here it said, get the row containing the Pokemon Luigi. So why not uh, change the indexing of the row and set the names of the Pokemons as the index, as the row labels, and then we can use the log function to simply find it. So I think uh, as for rows, as it goes for rows, I mean, if you know what you're looking for, then this kind of approach is maybe the best to not to make mistake, right? I mean, if this is a row 4 or 5 or 25, that can be sometimes difficult. All right, exercise number 2. So here you were deleting columns or combining columns together. I think that was not a big problem. So to get rid of columns, you can use this data drop, but don't forget, drop does not actually delete the columns. It just sort of hides them from you. So you have to create a new data set. And again, usually it's good to keep the original data set intact and create new ones. I mean, again, depends on the situation. So here we use the drop function. And if we want to combine some columns together, we can use a concat. And what we have to be careful about here is what kind of axis we are using, along which axis we are working. So next we do slicing. Well, as you can see, the slicing works pretty much as before. If you're if you're slicing through the rows, so you just have this slice like in the case of arrays. If you're slicing in columns, then what you are doing is, so you first slice through the column labels, right? Here, data columns. So this gives me a list of all the labels. So I slice through those. I'm gonna take the last 3 ones, and then I'm gonna use that. So what does this produce, right? Is a list of the labels, and then I'm gonna put here the list of the labels here, or an array of the labels, to as an index, right? So so that's another thing that we've already seen. Before, and yeah, and here's a combination. Here's a combination of both, right? First you choose the columns, and then you choose the rows, right? Some basic statistical operations. So find the total number of Pokemon that are legendary and the total number of Pokemon with evolution. So um, so now, for example, here we have three different solutions. So one is, well, if you don't know really much about pandas on its functionality, well, you can just go with the for loop. You just loop through the column, and under the condition that the Pokemon is what here legendary, then you add one. Okay, or you can use NumPy. If you know NumPy, you know how to get the counts of zero or non-zero values. So here, in this case, the the Pokemon is legendary or not, right? So that would mean, I mean, here in this data file, it means yes or no, but basically the idea is, right, it's like a 0, 1. So what we can do is we can use the mapping. We've already seen this map function. So we can take the data in the legendary column, we can map it from yes and no, we can map it onto 0 and 1, and then we use this numpy count non-zeros, and that gives us exactly the same result. Or okay, or here we are calculating the evolution. I mean, it's the same thing, just a different parameter. And what we can use, so we set a simple for loop, conditional for loop. We can use numpy function count non-zero, or we can use pandas value counts, right? The pandas value counts, it gives you counts of frequency for all the different data that appear, that if they are the categorical data, right? So here we had the categorical data, we had the category either yes or no, so that gives me basically another data frame with just yes, how many times it appeared, no, how many times it appeared. And then if you know how this list is organized, then you just choose some to show a part of it. So again, the same thing done in three different ways, depending on what you are used to or what is useful. But you could kind of should have an idea that there are all these different ways. Now we're supposed to find a Pokemon with the weakest and strongest power. So again, let's say like the straightaway easy thing is to for loop through the data of the power. But here, what we want, right? So this is the kind of thing that you are going through one list, or what from through one column, but you also want to keep track of what's happening in another column, right? I mean, here we go. So what we do here is we use the minimum and maximum functions to find out where is the minimum power, what is the minimum power, and what is the maximum power. And now you would say, I mean, what you would do normally, right? If it was just a list of paper, you would say, okay, I'm gonna go through the column with the power. When I find the one that I know that the minimum is, I don't know, 50. So when I find the one with 50, I'm gonna go in that row and take a look what's the name of the Pokemon. But how do I do that? Well, in Python, usually the way you do it is you have to go through, when you go through the column and you're checking here, you also have to go at the same time through the column of the names if you're using the for loop. So this is why we use this for I and D, and we have this enumerate data power, because this gives me the couple of the index, and the value of the power here, index, is the index of the row, so I know which row I am in. All right. Next thing, find average power of legendary or non-legendary Pokemon. Well, what? Well, average power, that means just add all the powers of, for example, the legendary ones and divide them by number of the legendary one, similarly for the non-legendary. So there is a really there is a very simple for loop solution to that. But also there are other ways, of course, how to do it. And so here in the exercise, in the fourth part of the question, find the mean power based on the region column. So you want to know for each region what is the for each region you want to know what is the average of the power, and that you can do by this function group by, right? So this function group by, what it does, you give it the column called region, and it's gonna group all the Pokemon that have the same region. And now the question is how, what's gonna do with their data? What it's going to do with their data? Well, if you put mean here, it's gonna create the mean of this data. All right, and then we are interested in the mean of the power, so we call the power. You could say, I mean, what happens with the legendary or the evolution? Well, you can try to call here legendary or evolution. So again, so nice thing about this, which has merits and doesn't have merits, is that this is going to create going to create a new data frame that will have all these means done by over the region, whether they make sense or whether they don't make sense. All right. I mean, as we know, the data frame can be missing information, or there might be not, or there might be none there. So that's not a problem. All right, and so like I said, the most problems was here with the conditional replacement. So here we see, and this is something more directly connected with what we do in the data science class. So sometimes the data set needs to be fixed, right? And I'm going to be talking about it in the next video. And so here it's very simple. If Pokemon is legendary, it cannot have an evolution. Now, if I'm going to look at the table here of the Pokemon, I see that there is some, for example, here, Latias. I'm sorry, I'm not really a Pokemon fan, so I don't know how to read those names properly. So this Latias guy, he's legendary, but it says that he has an evolution, and by the law of the Pokemon world, he shouldn't have. So we need to fix this. So, and indeed, we don't want to fix this by hand, one by one, because, well, I don't know. Here is a list of 10 Pokemons, but I have a feeling that there is millions of them. I mean, it's a whole world, so who knows? So we have to do it in a smart way. And so here, here you have several ways how to do it. So one way is to use the function where. So this function where, what does it do? It replaces the values where some condition is false. So what we do here is, so we're gonna take the column Pokemon data, the evolution column, and on this column we put where, and it says here, here's the condition: Pokemon data legendary is no. So it's the condition if the Pokemon legendary data is no, sorry, then replace it with no. And so here this might be confusing at first, because I mean the idea was if legendary is yes, then evolution is no. But the point here is, again, you should read up on the manual. Replace this function where replace values where the condition is false. So you cannot put here Pokemon data legendary yes, you have to put here no, because the condition is evaluated when it is false. All right, so that's another thing. One has to be careful whenever you're using something, some kind of this kind of functions, and they're depending on the conditions. You have to know whether the function takes the actual Boolean value of your statement or of your condition, or if it takes its negative, or I mean if it goes with the if it goes with true or false, right? So that also happens. Sometimes it's this way and sometimes it's the other way. Another way how we can use here, I just wanted to show. So All right, and so here, what we do here, again, like the simple thing, so we want to rewrite this time we want to rewrite this because, well, we don't need a data file with wrong data. So here we just rewrite the column in the data file. All right, so that's one way to do it. Or maybe more nicer way is with this where function also has the parameter in place, so we can just do in place true, and we just call this and it will change the data set. Or we can also do this using lock and a boolean masking, so we can uh, what we want is we want to access the column evolution. We want to access the data in the column evolutions, but only on the rows where legendary is yes, right? And so this is basically here we can use this boolean mask. So if Pokemon data legendary is yes, so choose those rows, then in the column evolution, and then change this from yes to no, or from whatever is there into no. All right. So that's all for this time. Thank you and see you in class.